Hello, welcome to STR8CHEM, and now we're going to talk about how to draw or how to construct the most plausible Lewis structure for NOCl. The first step we need to do is to count the total number of valence electrons involved in the construction of the Lewis structure. Okay, so as you can see just now, we have we're going to involve N, O, and Cl. So there are three elements involved in the construction of that Lewis structure. We have nitrogen, oxygen, and chlorine. Okay. Valence electrons. There are two ways to identify the number of valence electrons. Number one, through memorization. If you can memorize the position of each of the elements on the periodic table, you can do that. Or you can go straight to the table given to you in exams and try to use for example, oxygen. You have proton number equals to 8. So the SPDF notation is 1s2. 2s2, 2p, 4, 5, 6, 7, 8. And then when you look here, that is the outermost shell. Therefore, you have 6 valence electrons for oxygen. So that is another way of doing it. So you have 6 over here. Okay. Alternatively, you can try to memorize the position. For N over here, I do remember that nitrogen is situated on group 15 in the periodic table. Therefore, group 15, 1, 5, you have 5 valence electrons. And chlorine is on group 17, therefore 7 valence electron. Okay? So when you look at your structure here, you have 1 nitrogen atom, so times 1. You have 5. You have 1 oxygen atom involved, so you have 6. Times 1 over here as well. Then you have 7. Therefore, the total valence electrons involved is 7. Plus 6 is 13. Plus 5, you get 18 valence electrons. Okay, so by writing that, you will be able to get 1 mark. Okay, so you can double check. 6 plus 5 is 11. Okay, 6 plus 5 is 11. Plus 7, you get 18. It's very important for you to write valence electrons right over there to give the impression that you do understand only valence electrons is involved in the construction of Lewis structure. Okay, step 2, we need to draw the Lewis dot symbol. So between N, O, and Cl, okay, between N, O, and Cl over here, the most electropositive element would be nitrogen. So I'm going to put nitrogen as the central atom right over here because nitrogen is situated in group 15, oxygen group 16, chlorine group 17. So when you move across the period on your periodic table, electronegativity increase. Therefore, nitrogen will be the most electropositive. So it will be the central atom. And then oxygen will be the terminal, followed by your chlorine over here, also the terminal atom. Okay, so that is your central atom. Okay, and that one is your terminal atom. Why is it central atom? Again, I repeat, because N is the most electropositive atom. So the most electropositive atom will be the central atom. Okay, so that is not very difficult to remember. So now we're gonna draw the Lewis dot symbol for all of them. So how do you do that? So you can go back to the slide over here. You can see that the number of valence electron is 5 for nitrogen, 6 for oxygen, 7 for chlorine. So for nitrogen you have 5, 1, 2, 3, 4, 5. For oxygen you have 6, 1, 2, 3, 4, 5, 6. For chlorine you have 7, 1, 2, 3, 4, 5, 6, and 7. So by drawing the correct Lewis dot symbol for each of the element involved, you get 1 mark. Okay, again, don't forget the one in yellow over here, the one I have highlighted in yellow, those are your lone pairs. Okay, lone pairs. And then the one I'm highlighting in green, 1, 2, 3, 4, 5, 6, those are your unpaired electrons. Okay, so those are your unpaired electrons. Moving on to step 3, you need to draw the bonding pairs. Okay, you need to draw the bonding pairs and lone pairs. So I'm just gonna redraw the Lewis dot symbol. Okay, so you have your unpaired over here to combine with that unpaired over there to form one sigma bond bonding pair. Okay, and then we have one unpaired over here to combine with that one unpaired over there on the nitrogen to form one sigma bond. And don't forget, you have another unpaired over here and that unpaired over there to form another bonding pair, but this time it will be a pi bond. Okay, so you can double check. We go back to the slide over here. You can see that we have identified there will be 18 valence electrons involved in the formation of this Lewis structure. So we can double check. Do we have 18? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you have 18 valence electron. Hence, this is correct. Okay. Now, how do we determine the formal charge? If they want you to determine the formal charge, so this is how you're going to do it. We have oxygen over here, double bond N. Okay. So we're going to do for all three, formal charge for N at NOCl. So the formula is you're going to have 5 valence electron minus 2 electrons at the lone pair for the nitrogen minus 3 bonding pair. You have 0. Okay, so over here you have 0 formal charge. And then what about oxygen? So formal charge for oxygen at NOCl, you have 6 valence electron minus 1, 2, 3, 4, 5, 6 6 over here. Sorry, that one you have only. Okay, so you have 1, 2, 3, 4. 4 electrons at the lone pair minus 2 bonding pair. You have 0 formal charge, so you get 0 over there. And then you have formal charge for Cl at NOCl. Cl, chlorine has 7 valence electron, minus chlorine has 3 lone pairs, so you have 6 electrons at lone pair, minus 1 bonding pair, you have 0 formal charge. Therefore, over here you have 0. Okay, so you get 1 mark there, 1 mark there, 1 mark there, and 1 mark of right over there.